Continuing with organic chemistry, let us do some important questions. Number one is, what are saturated and unsaturated hydrocarbons? So saturated hydrocarbons, they contain all carbon-carbon single bonds. Example, all alkanes, and they are derivatives. They all are saturated hydrocarbons. Then we have unsaturated hydrocarbons. They contain at least one double or triple bond in them. Example is ethylene. It is alkene, unsaturated hydrocarbon, and acetylene having triple bond. It is another class of unsaturated hydrocarbon. Then we have define Huckel rule. Huckel rule, it states that cyclic systems having 4n plus 2 pi electrons are aromatic in nature. And in this case, benzenoid as well as non-benzenoid aromatic both come under this category. Example, we have furane. It is a 6 pi system, 4 pi and 2 pi electron, these are entering in the resonance. Then we have thiophene. It is 6 pi system, and pyrrole. This lone pair of these atoms that is involved in the resonance, and all of them they are having 6 pi system. So these are non-benzenoid aromatics or heterocyclic aromatics. Then we have benzenoid aromatics. They have 4n plus 2 pi electron in the cycle of carbon atom. This is benzene, toluene, phenol, aniline. They all are aromatic. They are called as benzenoid aromatics. So these are the aromatics, benzenoid and non-benzenoid. Then we have the next question. Define functional group. Give some examples. For functional group, it is an atom or group of atom which is responsible for the characteristic properties of the compound. For example, OH, it is the functional group of alcohols. Then COOH, it is functional group of carboxylic acid. Then we have NH2, amines, ketonic group, CHO group, it is aldehyde group. So these are all called as functional groups. They are responsible for the properties of the compound. Then what is homologous series or homologous family? This is our question number 4. Define homologous series. Give its characteristics. So we have homologous series. It is the series of structurally similar compounds which have same general formula, similar methods of preparation. Their chemical properties are same, but their physical properties show regular gradation change when we move from top members to bottom members, and adjacent members they differ by CH2 group. So it is series of structurally similar compounds in which members possess same general formula, functional group, similar chemical properties, and adjacent members they differ by CH2 group. So what are the characteristics? Number 1, they have same general formula, same functional group, adjacent members differ by CH2 group, similar chemical properties, physical properties, show regular change, similar methods of preparation, so these are the characteristics of homologous family. Then we have next question, what are the different parts of the IUPAC name of a organic compound? So this is very important question. Now we are switching to the nomenclature of organic compounds. So this is our question number 5. What are the different parts of a IUPAC name of an organic compound? As in our case, our name consists of 3 parts. One is the name, second represents our religion, and third represents our community. So suppose a person is Ram Kumar Sharma. Ram indicates he is Hindu, Kumar indicates he is not having he is a not Sikh, and then he is Sharma, so that he belongs to a category of wise people, Brahman. Similarly, we have the name, 3 parts of the organic name. For example, we have a name 3-chloro-pentoene one ol. Now here, this is called as prefix. This is pent. This indicates word root. In it is secondary, primary, suffix, and this is secondary suffix. So the name of organic compound consists of three parts. Number one is prefix. These are the series of words which come in the beginning before word root. There are two types. Primary prefix is cyclo. If there is cycle of carbon atoms not having benzene ring, then it is cyclo is used. If we say secondary prefix, these are the names of substituents like chloro, bromo, hydroxy. So these names which do not come in the selected chain. Then we have second word root. It tells us about the number of carbon atoms in the selected state chain or cycle of carbon atoms. Meth for 2 carbon, prop for 3 carbon, but for 4 carbon in chain or cycle, pent for 5, X for 6 carbon, F for 7 carbon, Op for 8 carbon, Non for 9 carbon, and so on. Then we have suffix. The series of words which are used after word root. Here are of two types. Primary, it is in, ein for triple bond, an for single bond between carbon and carbon, in is for double bond between carbon and carbon. Then we have secondary suffix. These are the specific ending of functional groups. So these are secondary suffix. For example, for alcohol, secondary suffix is ol. For carboxylic acid, it is oic acid. For amide, CONH2. CONH2, we use amide. Then we have CO group, we use on, ketone. Then we have CHO group, we use al. So these are the three main parts of the name. Now let us write the name of this compound. First of all, take the word root, 5 carbon. No cyclo is there, so they will be in the state chain 1, 2, 3, 4, 5. 3 is having chloro, put here Cl. 2 is having double bond, 1 is having ol, put OH here. Now every carbon should be tetravalent. So it will be CH2, it is CH, CH, CH2, CH3, this is compound. If there would have been cyclo before this word, then we would have made 5 carbon cycle. Carbon number 3 would have been having Cl, carbon number 2 having double bond, carbon number 1 having OH group. Now make the valency of each carbon as tetravalent. So this would have been the structure of that. So if cyclo is not there, you have to make the chain of the carbons which are indicated by word root. If cyclo is there, then you will have to make the cycle of those carbon as are indicated by the selected chain. And then we'll be doing the rules for naming of the your organic compounds. So what are the rules, will be discuss those rules in the next lecture, and then we'll name the compound without functional group, then with functional group, and then the compound having the multifunctional groups which are having large number of functional group, 2, 3 or more than that. So we'll be dealing them in the next lecture. Thank you very much.